Okay, let's use the chain rule then to work out these in question 3. Something squared, so we differentiate the something. So something squared power rule, 2 times something, so the 1 less is 1, multiplied by the something differentiated, 0 and 1. So that's equal to 2x plus 1. We could write it that way round. This one, something to the 6, differentiate the something, 6 times something to the power 1 less, multiplied by the something differentiated, which is 0, and that goes to 7. So that's 42, 1 plus 7x to the power 5. Okay, the next one, something to the power half, is half of the something to the 1 less, to minus half, multiplied by the something differentiated, 0 and 8x. So we end up with 4x. And we could drop this bracketed term underneath, couldn't we, if we wanted? 1 plus 4x squared to the half, instead of writing it as minus half on top. Here, something to the minus 1 is minus 1 of the something to the 1 less, power rule, multiplied by the something differentiated, 2x and 0. So that's equal to minus 2x then, over, and drop this bracketed term underneath and flip the index using properties of indices. Okay, next one, 5 lots of cos of something's cos of x squared. Now this is cos of x squared here. It's not, the 2 is not here. So it's cos of something. So cos of something goes to minus sine of something, and there's 5 lots of, multiplied by the something differentiated, which is 2x. So it's minus 10x sine of x squared. Next one. Sine of something differentiates to cos of something, doesn't it? So it's cos of something multiplied by the something differentiated. This differentiates to 2. So we equal 2 cosine 2x minus pi over 2. Next one, sine of a half. Well, what we mean by that is we mean, and I'm going to write it more long-windedly, we mean sine x all to the power half. That's what we mean. So do by dx then. Something to the half, use the power rule. Half times the something. Differentiate the something. 1 less, use the power rule. Multiplied by the something differentiated, which is cos x. So this is equal to cos x over, and drop this underneath, sine, I'm going to write this as half here, looks easier on the eye, and the 2 is there with it, isn't it? Next one, this can be written as tan x squared, can't it? So let's write it more long-windedly, because then we can see the substitution, something squared. So divide dx then, something squared, use the power rule, 2 times something. Power comes down to the 1 less, and tan differentiates to sec squared x on the table of standard derivatives. So it's 2 sec squared x tan x if we wanted to tidy it up. So let's move these down. Hopefully we've got room to move them all down. Yeah, we have. Let's just move these down. A little bit more room. Okie dokie. Right, next one. Divide dx. Power rule. Something to the 4 is 4 times the something to the 1 less, multiplied by the something differentiated. Now the something itself is a function of a function. So when we differentiate this, sine of something goes to cos of something, multiplied by the that something differentiated, which is 3. So we had a sub-problem there, didn't we? 12 sine cubed, I'm going to write like this, 3x cos x. So I'm just going to mention that again, just run through it again. When we looked at it from the outside, it's something to the 4. So use the chain rule. 4 times something cubed multiplied by the something differentiated. Now in turn, that something differentiated is itself a function of a function. So we can unravel it again by differentiating it. The sine of this something goes to cos of something multiplied by that something differentiated, which is 3, and then we write the answer down. So work your way from the outside in till you get to the innermost part. Sometimes you've got to do process over and over, as we did here. E to the x cubed, so the something e to the something goes to e to the something, differentiates 2, multiplied by the something differentiated. This differentiates to 3x squared. So we've got 3x squared e to the x cubed. Next one, dy dx. We've got log of something goes to 1 over, doesn't it? 1 plus 3x. 1 over the something multiplied by the something differentiated. 0, and this goes to 3. So we've got 3 over 1 plus 3x. Next one. Y equals log 1 plus cos x. Dy dx then. Log of cos x rather. Log of something goes to 1 over the something, multiplied by the something differentiated minus sine x. And you can write that as minus tan x if you wish, because sine over cos is tan.